Welcome to the deep dive. You gave us a stack of sources detailing one of the most critical transformations happening in education today.
The shift from paper-based exams to on-screen assessment, or OSA.
Exactly. And this deep dive is your shortcut to understanding the entire landscape. Not just the glossy brochure of digital benefits, but the concrete cognitive and logistical risks that researchers are now flagging. Okay, let's unpack this. Our focus today is on understanding the mode effect.
Right.
That's the core concept here, and it refers to any measurable difference in how students perform on comparable tests just because the medium of delivery, the screen versus the paper, has changed.
And that mode effect is, it's the entire ballgame. Our mission is to provide you with a balanced understanding of this trade-off. We're looking at research primarily centered on high-stakes qualifications.
Like those massive national exams.
Exactly, because that's where the consequences of getting this wrong are highest. We see these powerful digital tools that promise efficiency, but we also encounter these, deep cognitive hurdles that make predicting the final outcome incredibly difficult.
Because the data is still kind of mixed.
It's very mixed and highly contextual.
Let's start where the optimism is strongest. The digital upside. The research is very clear that students overwhelmingly prefer taking exams on screen. Why is that?
It really boils down to control and comfort.
Okay.
Students cite the convenience of the assessment mode, the desire for immediate or faster feedback, and just the greater flexibility digital platforms offer.
And it feels less stressful to them.
Crucially, yes.
Yes.
Many students and their parents perceive OSA as less stressful, and frankly, they just see it as inevitable. It's how the world works now.
And that preference translates into a specific physical preference, doesn't it? The desire to type rather than handwrite a long response.
Absolutely. Typing versus handwriting is one of the key drivers. Handwriting is consistently linked to two major performance distractors.
Which are?
Lower legibility, which
Yeah.
forces examiners to sort of guess what was intended, and then significant physical discomfort, especially in those lengthy timed assessments. Typing just eliminates both of those hurdles.
It's just faster and easier.
Generally.
Yes. I can appreciate the comfort factor, but does that comfort actually make their work better? We're talking about high-stakes writing here, not just, sending an email.
It actually changes the structure of their thinking, which often leads to quantifiable improvements.
How so?
For extended writing tasks, the ease of editing on a screen fundamentally alters the composition strategy. Students can replace micro details, like swapping a word out, or reorganize entire arguments using macro formatting.
Just dragging and dropping paragraphs around.
Exactly.
So the shift is it's a shift from rigid upfront planning to a more fluid on-the-fly composition.
Precisely. When you're writing by hand, the need to avoid messy crossouts, it kind of compels students toward more detailed upfront planning. Typing liberates them. They can get the basic argument down and then focus on refining the structure and language later. The result is often responses that are statistically longer. We saw one finding of an average of 183 words typed versus 160 handwritten.
So a decent amount longer.
And they also contain fewer errors per 100 words. The focus shifts from just transcription to true intellectual revision.
Okay, here's where it gets really interesting. This isn't just about writing more. The digital environment can actively reduce cognitive load in certain tasks, allowing students to show knowledge they might otherwise struggle to demonstrate.
The math example is the single most powerful piece of evidence for this digital advantage.
I found this part fascinating.
Yeah, we're looking specifically at tasks that allow for what researchers call exploratory trials, where you can try and fail safely without needing to erase or start over.
So tell us about that specific example from the sources.
So researchers analyzed a drag-and-drop math item. It required arranging specific digits to solve a problem. On the computer, students could rapidly shuffle the digits around until the equation was correct.
And the performance.
It was striking, 94.9% correct. But when the very same item was given on paper, performance dropped drastically.
What?
Down to 77.1%.
Wow. That's a massive difference for the exact same underlying mathematical concept. What accounted for that 17 percentage point gap?
Two things, really. First, the digital platform allowed quick, effortless trial and error, reducing the cognitive burden of calculating multiple possibilities in your head.
Okay.
Second, and crucially, the digital version eliminated the common pitfalls of the paper version, like students accidentally duplicating a digit or making transcription errors. So in this instance, the OSA truly improved the assessment experience.
It boosted performance by reducing what you call constructor-relevant variance.
Exactly.
So to synthesize the upside, OSA can eliminate physical barriers, poor handwriting, manual calculation errors that might otherwise prevent a student from showing their true competence.
Right.
But you mentioned significant cognitive costs earlier. If we flip this around, what does the research say about reading itself? Is there a cognitive hit just from reading a complex text off a screen?
We have to move now to what's called the screen inferiority effect, which is a central cognitive challenge in this transition. Multiple meta-analyses consistently find a small but statistically significant comprehension bias in favor of paper.
When you say small, what are we talking about in real terms?
The effect sizes generally cluster around -0.21 to -0.25.
Which sounds a bit academic. What does that actually mean?
Well, policy researchers confirm that effects of this magnitude represent meaningful shifts in student outcomes. To put that in perspective, an effect size of -0.25 is enough to potentially shift thousands of students across key grade boundaries in a national exam system.
Wow, okay, so this is a serious policy concern, not just an academic footnote.
It absolutely is.
That makes the why question essential. Why is the screen inferior for deep reading?
There are two main interlocking theories here. The first is the shallowing hypothesis.
Okay.
Studies using observation and eye tracking suggest that students reread significantly more when using a screen, indicating that their initial processing is more superficial or shallow. They tend to skim for keywords rather than engaging in sustained deep reading.
So the medium itself encourages superficiality. What's the second theory?
That's the metacognitive deficit hypothesis. This one is all about self-awareness.
How so?
Readers on screen exhibit poorer calibration accuracy. This is fascinating. It means they process the text less efficiently, but they mistakenly believe they understand it better than they actually do.
So a student might finish reading on the screen and think, yep, got it all, but when tested?
They've missed half the key arguments. They're overconfident in their shallow processing.
So when does this inferiority effect hit hardest? Is it always there?
It's highly moderated by the text itself and the environment. The negative effect is far more pronounced in longer text. We're talking over 500 words.
So an exam text.
Right, and especially in expository or informational texts, which require greater mental effort to follow complex arguments than, say, a predictable story.
That sounds exactly like a high-stakes exam.
Precisely. And now add time pressure to the mix.
Oh, boy.
The comprehension gap increases significantly when time is constrained. Paper scores tend to remain consistent, but screen scores decline sharply under pressure.
Why?
The cognitive resources needed to manage the digital interface start competing with the resources needed for comprehension.
And what about the physical act of managing the text? I know I find scrolling disruptive. Does the research back up that feeling that scrolling breaks your concentration?
Absolutely. The fixed location of text on paper provides spatial cues that aid memory and comprehension. The fluidity of on-screen text, which constantly requires scrolling, removes those cues.
It's just harder to remember where things were.
It is. Scrolling is linked to reduced comprehension, and this negative impact is especially strong for students with lower working memory capacity. The cognitive demand of just navigating the text competes with understanding it.
Moving past text, let's look at math and technical tasks again, but this time focusing on where the screen introduces new difficulties. Where does the most significant friction occur?
That happens in tasks requiring multi-step calculation, annotation of diagrams, or geometric manipulations. These are the kinds of complex numerical tasks that are typically much easier and more intuitive on paper.
Why are they harder on the screen if they aren't those drag-and-drop puzzles? Is it just tradition?
No, it's cognitive efficiency, or rather the lack of it. When working on screen, these complex tasks impose what researchers call an attention-switching cost.
Meaning what?
You have to constantly switch your focus and spatial orientation from the screen, where the problem is, to your scratch paper, where the working memory calculation is happening, and then back to the input box.
That makes sense. That act of moving your eyes and focus back and forth is distracting.
It is. And this frequent switching increases the likelihood of transcription errors and imposes a significant mental friction.
Does that mental friction also discourage students from using scratch paper altogether?
It does.
Yeah.
Studies show students are often reluctant to use the physical scratch paper when working on a screen-based problem,
So they just try to do it all in their heads.
forcing them to rely on purely mental strategies. For multi-step calculations, mental math is inherently more error-prone than externalizing the calculation. They are sacrificing accuracy for convenience.
Then there's the whole issue of inputting answers, what you called the tool problem in the sources. I can personally relate to that. Trying to input a complex equation or plot a graph with a mouse feels incredibly clumsy.
It consumes working memory that should be dedicated to solving the problem. The input mechanism is a major challenge, especially for disciplines like physics or advanced mathematics.
And what did the students and parents say?
The surveys showed they strongly prefer to write equations, quant graphs, and draw figures on paper. Inputting mathematical notation via on-screen editors is just much slower and far less intuitive than simply handwriting the symbols.
And if it's slower, does that discourage them from even attempting to show their work?
Precisely. If it's frustrating and time-consuming, students are discouraged from recording those crucial, credit-worthy intermediate steps.
And in assessment, showing your method is often as important as the final answer.
It is. Furthermore, even with a stylus, small-scale studies found physical constraints, like students being unable to rest their hand or arm naturally on the tablet while writing, which further increases effort and reduces precision.
And finally, integrating information seems harder when you only have one monitor.
That's a major display challenge. Spatial constraints on screen make it very difficult to integrate multiple sources, say a complex chart, a long text passage, and the 5 questions referencing both, all at the same time.
Whereas on paper, you can just lay them out side by side.
Exactly. On screen, tasks requiring navigation between multiple windows introduce significant extraneous load. Research shows this burden is drastically reduced if schools provide dual screens.
But that is simply not the standard in most exam halls today.
Not at all.
Okay, we've covered the cognitive upsides and the cognitive barriers. Now we hit the wall of reality. The immense logistical and infrastructure challenges facing widespread adoption. This seems like the most immediate barrier to fairness and scale.
It absolutely is. We're facing a massive readiness gap. The scale of resources required for mandatory OSA delivery is huge, and most schools and colleges are just not equipped.
What are the numbers on that?
We have indicative findings suggesting a median of just 1 suitable laptop for every 8 secondary school pupils.
1 for every 8. Wow.
And even if they had the devices, connectivity is a major hurdle. Unreliable internet, insufficient physical space for power and network facilities.
These are chronic problems, especially in rural or older school infrastructures.
And that infrastructure deficit means that successful international mandatory OSA deployments, they only really occur where digital readiness is already extremely high and universal access is assumed. For us, this technical gap inevitably raises profound issues of equity.
This raises an important question then. Fairness. The transition to OSA risks widening existing socioeconomic performance gaps because it overlays a new set of digital requirements onto the assessment.
Unequal access to digital devices at home is a foundational problem. We see that only a minority of students report having exclusive access to a computer device at home.
So students from more resource-rich environments gain essential fluency through daily home use,
while those without that access must try to develop those skills purely at school. And that lack of fluency can directly constrain performance in a timed exam, regardless of their actual knowledge in the subject.
That's where the keyboarding threshold comes into play, right?
That's it. Typing proficiency is a strong predictor of performance in on-screen writing tests. If a student's keyboarding skill falls below the necessary threshold, meaning they are hunting and pecking instead of touch typing,
then the effort of just typing gets in the way of thinking.
the cognitive effort required simply to type competes with their working memory resources.
In other words, the assessment has shifted. It's no longer just measuring composition skills, it's measuring composition skills plus typing speed and digital dexterity.
Exactly. We are introducing new sources of assessment variance tied to digital access and skill, which risks punishing students for non-academic factors rooted in socioeconomic disparity.
Finally, we have to acknowledge the deep-seated anxieties from stakeholders, the teachers, parents, and students themselves, that go beyond pure performance metrics.
The concern level is high across the board. There is high anxiety about technical failures during a high-stakes exam.
A system crash in the middle of a critical assessment is everyone's worst nightmare.
Absolutely. And there are also significant worries about assessment security, specifically the risk of plagiarism and the ease of sharing exam materials via digital channels.
And what about just well-being.
Let's not forget the warnings from stakeholders about the potential negative impacts on physical and mental well-being from increased overall screen time, particularly if assessments are lengthy.
Let's bring the synthesis together for you, the listener. We've seen that on-screen assessment brings powerful, performance-boosting affordances, ease of editing, getting rid of transcription errors, new exploratory strategies in math. But these benefits are heavily constrained. They are constrained by deeply ingrained cognitive effects like the screen inferiority for reading and the immense mental friction involved in complex tasks.
And then, fundamentally, they're constrained by the sheer lack of real-world logistical and infrastructural readiness.
What's fascinating here is understanding the core trade-off. The differences between paper and screen are not just about novelty. Many of these mode effects are intrinsic to the medium itself.
They are. And they often relate back to how we manage cognitive load. While some digital features wisely reduce construct irrelevant variance, like getting rid of the penalty for illegible handwriting.
Which is a good thing.
A very good thing. But other features inevitably introduce new variants, such as the demand of using a complex notation editor or the student's personal typing speed and home computer access.
This leaves assessment designers with a critical dilemma that goes beyond hardware. The move to OSA is not merely about translating a paper test. It fundamentally changes what is being measured.
Right.
If an item becomes significantly easier on screen because the digital tools allow students to arrive at a solution through efficient trial and error, but the paper version required them to demonstrate visualization or deeper conceptual analysis skills. Which version is truly assessing the intended understanding?
That question of construct validity is paramount for any educator or policymaker.
So we challenge you to consider what skills you value more in a digital world. The efficient, digitally aided response that leverages interface tools, or the deep, unassisted comprehension of complex text and the visualization skills required by traditional methods.